Hello students, in this video I will go through the last operation that we have not talked about yet this year. We started off talking about operating on polynomials at the very beginning of the year, if you may recall, and I stopped short on discussing division of polynomials. So the emphasis of this video will be about how we can divide polynomials. So before I talk about dividing polynomials, let's get back to basics. Let's talk about how we can actually just maybe perhaps divide numbers. Okay, so as you may recall from your early days in grammar school, okay, where you were first introduced to working with fractions, fractions and dividing numbers ends up being very similar. So in order for us to divide, let's say 18 into 288, okay, yeah, you can perform long division to figure out what that quotient is, or alternatively, okay, you can figure out whether or not 288 and 18 have any common factors, and from there you can sort of sculpt your way through, okay, getting at the final reduced form of this fraction. So immediately looking at this, I noticed that 288 and 18, they're both even numbers, and they're both therefore divisible by 2. So this is going to reduce to 144. This is going to reduce to 2 times 144 over 2 times 9. And I look at 144, and I immediately notice, wait a minute, 144 is the same thing as 16 times 9. And the denominator, I didn't do anything. And from there, I can see that the 2's cancel, the 9's cancel. This all reduces to 16. So that's one way for us to figure out the division of 288 by 18, okay? And this, in my opinion, can be more useful than performing long division, because sometimes long division just requires, really mindless work. And if you can figure things out in a more efficient manner, that is always the better way to go, which often factoring, tends to be that way. All right, let's take a look at another scenario. All right, so now I have 125 divided by 4. And in this case, here I can tell immediately that, the single digit there, that's a 5. So that means 125 has to be multiples of 5. And because I'm dividing by 4, it looks like I may be out of luck in trying to reduce this fraction, or trying to figure out the division in the same manner I did with the previous example. So what I'm forced to do in this case, because there are no common factors, I am kind of forced into figuring out what this is by long division. So in order for me to figure out how many times does 4 go into 125, I'm going to write it out like this. And I can see here 4 goes inside of 1 0 times, so I need to go into the next placeholder, right? So 4 goes inside of 12 on the other hand, 3 times, and I subtract 5, and I notice that 4 can go inside of 5 once with a remainder of 1. So in other words, okay, this 125 over 4 can be reduced to 31 and 1/4, right? It's really important that people understand this, right? When we say 31 and 1/4, what we really mean is 31 plus 1/4, and that's what is insinuated, okay? So this mixed number, okay, when put together, there is that implicit addition that is implied, okay, that you should be aware of, okay? There has to be a plus there. Why am I telling you this? Because in the next examples that we go through in a more abstract sense, okay, this idea comes back. So let's take a look. All right, so now we get into a little more abstract scenario where we're dividing polynomials. Now we're getting to the heart of what this video is about. And first thing that you would do, you would want to check to see whether or not there are any common factors. Is x squared plus 3x plus 2 reducible? Is it factorable? And you check and you look, and yes, it is. It factors into x plus 1 times x plus 2. And the denominator doesn't reduce anything, doesn't reduce any further. And looking at this, I see there's a common factor between the numerator and denominator, and that reduces to x plus 2. Lovely. So from here, right, there's nothing else that I can do with this. It just reduces to x plus 2. Let's take a look at the next example here. Can I do something similar with this fraction? Absolutely. Okay. X to the fourth minus 16. This is a polynomial with a quadratic form. This reduces to x squared minus 4, x squared plus 4, all over x plus 2. And then this further reduces to x plus 2, x minus 2, x squared plus 4, all over x plus 2. So this reduces to that, and I am left with this product, x minus 2 times x squared plus 4. So technically, yeah, that is my answer, but I want to write it out as a polynomial, as a single polynomial, but not as a product of two binomials. So this is really x to the third plus 4x minus 2x squared minus 8, or x to the third minus 2x squared plus 4x minus 8, written in descending order in that form. Okay? Let's take a look at the next example here. So in this case, now that we had gone through factoring the numerator and denominator, right? There's really nothing in the denominator for us to factor here. We can immediately tell that x plus 1 cannot divide evenly into x to the fourth minus 16. So what are we to do in this scenario? Well, you know how the example that I had gone through with you guys with an actual number, not an expression, right? Not an abstract expression like this. So we can actually operate on polynomials just like we would on real numbers. So I'm going to rewrite this, okay, in the same manner in which I am going to operate on a actual number. So I rewrite it and I make it look like this. So what I'm going to do with this now, okay, is I'm going to perform long division. And it looks really, really strange to be able to operate on this, doesn't it? So what I do with this, okay, is I can't really perform the necessary division yet, okay, because we're going to run into some roadblocks. So I'm going to preemptively show you there's something that we can do to account for some issues, to prepare for some issues. So there are some missing placeholders in here that are not directly written. So what I'm going to do is, okay, I'm going to express the missing terms that's in between, and I'm going to give it some space. So I have x to the fourth here. The next term that follows x to the fourth would be x to the third, right? But I can't just add x to the third. I'm actually adding 0x to the third, because 0 times anything is 0. Isn't that right? 0 times any number, that is, any real number, okay? And x here does represent a number. And then the next placeholder I'm going to add in is, you guessed it, x squared. I want to move this. There's going to be yet another placeholder, and that is plus 0x. Now that I have all these placeholders in place, okay, I am going to go through performing the long division. So I have x plus 1, and I need to divide this into, because x plus 1 is a binomial, I will be dividing that into the first binomial I see, and that is this guy right here. And the way in which we approach this is, okay, what do I have to multiply x by to get x to the fourth? Well, I would have to multiply by x to the third. And I'm going to place x to the third over here on top of the placeholder for x to the third. Do you see the similarity right, in performing long division with an actual number here. So I take x to the third and I multiply x plus 1 with that. And what I get is x to the fourth plus x to the third. And just like with long division, I am going to perform a subtraction. And I'm going to subtract. When I do, I'll end up with negative x to the third. So the next thing we're going to do, okay, normally what would happen is this number then would come down, right? So I'm going to actually write that plus 0x squared. So what am I going to multiply now to cancel out the x to the third? I will multiply x plus 1 by x negative x squared. So if I do that, I'll end up with negative x squared times x plus 1. That will turn into negative x cubed minus x squared. And again, I am going to perform that subtraction. This is how I perform long division. So this becomes positive x squared. And again, I want to pull this guy down. Plus 0x. So what am I going to multiply x plus 1 by to get x squared? Again, I want to multiply by plus x. So I get x squared plus x. And I perform that subtraction. I'll end up with negative x. And the last thing is I want to pull down that 16. So it's going to be minus 16. And what am I going to put in here? Or what am I going to multiply x plus 1 by? To cancel out the negative x, I want to multiply by negative 1. So I get negative x minus 1. And I'm going to perform that subtraction. And if I do, okay, I'll end up with negative 16 plus 1, which is negative 15. So my remainder then is negative 15. Right? Remember this in grammar school, right? Remainder of negative 15. So this fraction that I originally intended to divide, okay, would turn into x to the third. I'm going to write out a mixed number, right? X to the third minus x squared plus x minus 1, and then the remaining fraction. But remember, there was that operation that needs to be put in. Plus negative 15 over x plus 1. So that's what that original fraction would turn into if I were to perform the necessary division.